Hello and welcome to another stream. I am your host, as always, Justin. Welcome. Today is going to be a very fun day. We're going to be talking about easily my favorite material. This is truly the most versatile material on Earth as far as I'm concerned, because there are a few things that cannot be solved with, have you considered adding chitosan? And so we're going to talk about what is chitosan, where it comes from, how you make it, what it can be used for, all that kind of thing. However, as you know, this is a biohack chat, which means, as always, we're going to be having a wonderful discussion with my good friend, Gabriel Licina. So without further ado, everybody, this is Gabe. Say hi, Gabe.
Hello! As you guys know, I'm Gabriel Licina. I work for a 501c3 nonprofit called Sci-House, and we do research and environmental remediation, and sometimes educational outreach, and sometimes we just talk with Justin, and that's what we're doing today. About our favorite thing, CHITOSAN.
Yes, this is one of those things where I think we've been excited about CHITOSAN the entire time we've known each other.
Okay, excited doesn't even touch.
Yeah, okay, fine.
Yeah.
Like rabidly fangirling about a compound, which is like weird, but so are we, so fuck it, that's fine.
Also, it's just super cool.
It is
there's
super
nothing
cool.
wrong with appreciating, you may not like it. That's what peak performance looks like.
Yeah. So okay. So let's just jump right into it. Because why not? Okay. So let's talk about what is chitosan, and I believe this is okay. This is the chemical structure of chitosan. So chitosan comes from a material called chitin, and chitin is the main component of shrimp shells, crab shells, most crustacean shells, but also the cell walls of fungi. Chitin,
Yeah.
so chitin, the precursor to chitosan, is the second most abundant biopolymer on Earth, second only to cellulose. So
Yeah.
if it
Anything there's more than of chitin is plants.
yeah, and
We
that's
also love plants. So
that's the thing. These are our two favorite biomaterials: plant and the thing that is plant. And then everything else is just meat, but meh.
Yeah.
But yeah, so it starts as shrimp shells. So let's look at the chemical structure really quickly. You can see that it's a long chain of sugars. The little dotted lines on the end here means that this just repeats. So it's are you holding a okay? So Gabe is holding a jug of chitosan powder.
I'm holding a mason jar of chitin.
Yeah. One of the nice things about it being so available on Earth is that it's extremely cheap. So, like, you can get metric tons of the stuff for not a lot of money. But anyway, so the chemical structure of it is it's a long chain of sugar molecules, but you'll notice that it has this, there's a nitrogen group and an acetyl group on it. So to go from chitin to chitosan, basically what you're doing is you're removing some of these acetyl groups. And by doing this, you take something which is radically insoluble and making it soluble. So this means it's much easier to process and do stuff with, in comparison to chitin, which is basically just solid. Like, you can't really do much with it. But the nice thing is you can actually go back and forth between deacetylated and reacetylated. So, for example, if you get the chitosan into a shape that you like, a little lower, Gabe. There we go. So I'm gonna just go to Gabe's window.
So it's hard to see.
Yeah, so that you're a little higher. Little higher. You're just seeing the lid right now. There we go. So the stuff in the container that Gabe's showing is chitosan. It's a chitosan solution. Chitosan doesn't tend to dissolve very well in pure water, so typically what we dissolve it in is a little bit of dilute acid. So usually like vinegar, basically. So when you go from...
and we tested this. You
Yeah.
actually can't... It's like 3% chitosan.
is sort of
I feel like I lost... Yeah.
No, you're still there.
Okay, it's 3% chitosan to vinegar mass to volume ratio. But
And
it's
that's
like,
kind of the
yeah,
most you can get to dissolve
yeah,
initially.
we tried stronger. I even bought 76% acetic acid. This shit will burn a table. You need to wear a mask and goggles to handle it. Totally doesn't dissolve it more. So it's just like you just need a little acid. So you can just take normal kitchen vinegar
It's like
and
the
mix it in.
80s. It's just like the 80s. You just need a little bit of acid.
Yeah.
um, but yeah, so it's a really fascinating molecule, and we're going to talk a little bit, I assume, about how you get more concentrated solutions, because if you can do that, you can radically alter the properties of the thing you make it into. But we'll talk about that later. So the point is, you start with shrimp shells, and then you go through. Basically, you treat it with concentrated hydrochloric acid, then sodium hydroxide, then hydrochloric acid again. And so basically, what this does is it dissolves away any of the minerals, because you got to think that like crab shells, shrimp shells, these sort of things, they build minerals into their shells to add structure and
Yeah.
rigidity and this kind of stuff. Right, so you got to get rid of all that calcium. Then the hydroxide actually removes the acetyl group, so that's how you go from chitin to chitosan. And then the hydrochloric acid just neutralizes it and gets it back to like usable, essentially. Okay, so what can you do with chitosan? I mean, one of the...
Can't you do with chitosan?
I mean, the correct response is what can't you do with chitosan, because, like, seriously.
Okay,
Also,
so
somebody mentioned
let's be,
that...
like, super clear about this. Justin and I have known each other for...
I think 6 years.
6 years. And I think maybe once every 2 or 3 months, we run into a paper, and then we read the paper, and I'm like, hey, Justin. Or he's like, hey, Gabriel. And he's like, I figured out how the thing works. What's the secret? Well, they added chitosan. I'm not kidding. The number, like, it is a running joke for 6 years. That's how, because it does everything. You can make it into bioplastics. It's antibacterial. Oh, gosh, we got a whole lot to talk about.
Yeah, it's really quite amazing. Also, thank you, Nico, for kicking in. Just as a quick aside, as you can see, there's a donation bar. Any of the donations that come in today, which are greatly appreciated, are going to go towards getting some more parts for the bio robot that I have, which we talked about in, I don't think, 2 streams ago, I think. But yeah, so it's greatly appreciated. It'll help me get some projects going that are really exciting. So yeah, thank you everybody who donates. It's greatly appreciated. Anyways, getting back to chitosan, Gabe really isn't kidding here. Like, every single time that I'm like stuck on a problem, I'll just like go into Google and I'll type in problem chitosan, and almost always there'll be a link to some paper that usually solves the problem with they added chitosan. So for example, and so somebody asked, can you eat it? Yes, it's a fantastic source of fiber. Like, every problem can be solved with chitosan. So for example, we were working on
do I need to go get some of my chitosan and eat it on? Oh, I definitely have to get some.
Oh, good lord.
Okay. What?
Whatever. You'll have a good poo later.
I have so many samples though.
Yeah. So Gabe will do show and tell in a second, but like, so for an easy example, right? Like, I was trying to figure out a better way to do the lactase project, right? And doing the making myself lactose tolerant. And at one point I was like, I wonder if you can use chitosan. Oh, Jesus. I wonder if you can use...
It's not bad. It's just like,
really...
I'm literally eating insect shell.
It's gross. What's it taste like? I assume kind of vinegary and mostly like nothing?
No, look at this one. This one is actually processed really well. It literally tastes like nothing.
Okay. Cool. So
yeah.
you're eating bioplastic. Okay, that's fun.
Mm-hmm. What? That's the whole point of being bioplastic.
No, I know. It's great. But so, I was trying to figure out a better way to do the lactase project, and I just on a whim, I was like, DNA chitosan. Of course, not only does a paper pop up that uses chitosan to get DNA into intestinal cells, but they used frickin' lactase as the test subject. So it really is the thing that just solves problems. Like, we're like, I wonder, can it do, can we make it into bioplastic? Absolutely, yes we can. Here you can see a bazillion different images of people making it into bioplastic. Me and Gabe have been working on making like bioplastic. Yeah.
Of test samples.
Yeah, we've been making bioplastics out of chitosan for years in trying to find a good recipe that gets us all the properties that we want.
This one,
I made one.
Of my favorites.
The last one I made.
This is the lyophilized one.
Look
how freaking beautiful that is.
It is. It's a little. Here, I'm gonna make you big so you can do show and tell.
Make me big.
So yeah, that one's pretty cool. Do you have that rubbery one that I made when we were back in Florida?
Yeah.
So the last one that I made, because I haven't actually worked with chitosan in a hot minute, but the last one that I made was a mixture of chitosan and casein, so like milk protein, and the result with a little bit of glycerin, and the result basically looked and felt like rubber. Like, it was really, really cool. Like, it had a really great texture. Like, you could totally make that into like shoes. Somebody asked, are there any way to make chitosan that don't start with shrimp shells? I mean, you could do it with mushrooms, in theory. It's just not very efficient. Like, we produce so many... Yeah, there we go. Can you take it out of the bag? Because it's a little hard to see with the reflections. So, yeah, you can make chitosan out of other things, but shrimp shells are collected in such high volume. Yeah, so it's quite rubbery. It's flexible. It felt like rubber. Like, it's hard to see because the camera quality isn't super great. But
sorry for my shitty camera.
No,
I'm working on it.
It is the way it is. He does not moonlight as a cam girl. Yet. We'll
you have that 4K screen. You got to start questioning things.
That's always. I always find that really funny when you get into a Zoom meeting and like the one person.
Zoom meeting.
It's just like, why is your camera 4K?
On the other hand, you've got this guy.
Yeah.
This piece of chitosan, Pistachio and I made this, and this. Oh yeah. So we're thinking about sending this to SpaceX because. So this is a piece of organic material. This is basically like the largest chunk of insect shell that a person could possibly make. It doesn't burn.
I can't imagine that smells very good, but...
It doesn't smell like anything. You got a little bit of flaking there, but look at that. Surface integrity.
Huh.
This thing doesn't burn. I mean, you got a little bit of like random detritus. But you could just, like, sit here, look at this. I could do this all day. I could do this all day. That's pretty fucking cool.
That is pretty cool. So it's an ablative material. That's crazy.
Yeah.
Huh. Okay, then.
Yep. Oh, yeah, you weren't around for the blowtorch testing.
No, I was not. Okay.
Yeah.
And the thing is, I mean, you could just mix a little bit of graphite into that. Like...
Yeah.
Like, mix some graphite or some silica or something into that, and I'm sure it would work even better. Like, so this is the thing. It's also a really great base material. Like, you can mix other things into it. You can adjust its chemical properties. You can adjust so many different aspects of this material, and that's kind of what makes it so wonderful.
Somebody said something about making it a foam. I have a foam. Trust me, I've done all of this. Now, oh, look at this. I want to make sunglasses out of this. Like, I mean,
that's pretty good.
Anyway. Sorry, I'm looking for foam. Oh, here it is.
Yeah, I thought graphite, and then I realized that silica would work better.
Chitosan insect foam.
That's pretty cool. That's really, really cool. So, like, there's so many different things you can do with this. Like, these are all just bioplastic examples because, like, we did a lot of stuff with bioplastic, but, like, you can make so many different things with this. So here, let's talk about, because I mentioned transfection. I want to show this. I want to show this paper.
No, so we gotta go with the crazy story first.
Okay.
So I'm
tell
reading
me the crazy story.
Yeah. So, So I'm reading this short story called "The Scab's Progress," which is a short story by Bruce Sterling and I think it's Philippe DePolo. I don't remember the. And there's the one thing that I should have looked up before we started the stream. Yeah, Filippo Polidi.
Okay.
So it's yeah. So yeah, Poli di Filippo. And so it's a really, really great, like, if you like the whole I'm tired of cyberpunk, I want to read some biopunk, this is a fantastic story, and you can find it very easily. It's not like technically public, but it is. And so at some point, like, what I like to do is I like to read, and then you're like, wow, that's pretty cool. Maybe I could do something like that in real life. And one of those things was this helmet that one of the people, they were just, because it's all bio. Like, if you have a real world where bio is taking over the entire world, then everything is a biomaterial. And so one of the characters has a helmet made out of nacre, which is like the fancy science term for abalone shell or mother of pearl.
Yeah, nacre. I mean, we're still debating on how to pronounce it.
A little confused about how to pronounce it because we've never talked to anybody that says it out loud.
Yeah, it's one of those we've only read it kind of things, and so also I don't trust Google's pronunciation.
Don't judge. I just read. My bad. So this material is actually really, really strong. Like, super bonkers strong. And so if you had a motorcycle helmet made out of this, that would be fantastic. I'm like, okay, so how hard can it be to make this? Well, I found some papers. Justin, bring me some papers.
I'm already on it. So yeah, I've skipped to the bit where they show how this is done, but I'm just going to scroll up really quickly so you can see the name of the paper. It's called Synthetic Nacre? By pre-designed matrix-directed mineralization. So there's
this is in the library.
One second here. I'm gonna post the library link. There's a link to the library there.
Link. And if you join the SciHouse Discord, this is the type of stuff that we're trying to talk about.
Which, by the way, there's a link to that in the description.
Cooler than so many other things.
Yeah.
And so they make these sheets, and then it's like, okay, but what's the secret ingredient? Well, there's two secret ingredients. One of them is silk proteins. Justin, have you been working on silk proteins lately? I have been working
on silk proteins.
Yeah, and I've actually got a box.
I'm so close too. I think I'm actually finally close. Like, I think I've finally might have cracked it. I'm trying not to get too excited.
Yeah.
But there are some plates in my incubator which look like they might be alive, which would be very, very exciting.
So I've got a box in my lab storage that just says cocoons.
Yeah, they're silkworm cocoons.
Silkworm cocoons. And then, what's the other thing?
Chitosan.
Oh, it's chitosan.
Of course, it's chitosan. So just to give you the quick version of how this protocol works, basically you cast chitosan into sheets, dry it, and then you do that reacetylation process. So this is a chemical process, but you're basically making it so it goes from a soluble state to an insoluble state, so it can't redissolve. So you're basically turning it back.
We're going backwards.
Yeah, we're going backwards, back to shrimp shells. But it's now sheets of shrimp shells. Then once they've got the sheets of shrimp shells, they stack them, and they perfuse them with a calcium carbonate solution, as well as a little bit of magnesium, and then once it's been mineralized, they backfill it, or kind of at the same time, really. They essentially mix it with silk proteins, which in this case came from, I believe, silkworm cocoons. So you basically have this mixture of calcium carbonate, chitosan, and silk, and then they hot press it at 80 degrees into these hard sheets, and the end result is it works. They end up with actual, like, nacre. So this is pretty freaking wild. Like, the fact that this is that easy. I mean, I say that easy as if that isn't a lot of steps, but like, it's doable.
It's super cool. And then you just make giant chunks of mother of pearl, which is this super strong material. Like literally, bullets are going to bounce off this thing if it's this thick.
Yeah,
That's so cool.
It's pretty neat. And because it's got it's a composite material, right? Like because it's got the layers of chitosan, it's got the silk, it's got all this different. Excuse me. Got a bit of cereal go down the wrong pipe. Sorry about that. Anyway, but it's a really neat material. So, speaking of making things out of chitosan, we can't talk about making things out of chitosan without talking about our favorite researcher. This is Neri Oxman. She is amazing. She runs
except for her method section.
Except for her
I
method
hope you're
section.
watching, Mary, so that you know that
you went from writing really great method sections to the absolute fucking worst.
But still, she's awesome.
She is awesome. Like the things that she makes and her team makes are just fantastic. She runs a chunk of the MIT Media Lab. She's just a dope ass researcher. So one of the things that she made were these gigantic 3D printed, computationally designed chitosan wings. So here's a picture of them there. Yeah.
Giant dragonfly wings.
Right. Because the thing is, at heart, she is an artist. And so she tends to make art, but to do so, she does a lot of really dope ass science. So when I say computationally designed, what I mean is that their team figured out the pattern of the chitosan that they can print that will make the thing fold as it dries. So they basically like extrude this like chitosan gel on a flat surface, and then through computational design, they've been able to figure out how it's going to curl and like change its shape as it dries, and so they can control this as it does the thing.
So like chitosan, at its core, is still technically chitin is not a hydrogel, obviously, but chitosan is a hydrogel unless it's aggressively cross-linked.
Yes.
Which means that it's going to absorb water and it's going to change form. And so these wings will actually change shape depending on the humidity of the room.
Yes. And I mean, they can also be chemically cross-linked afterwards.
They figured out how they're going to bend.
Yes.
This is so cool.
And also, because it's Neri Oxman, of course, that was not where they ended the project. They're like, oh, but there's all these little bubbles inside of the chitosan. What if we just filled those with genetically engineered algae that makes medicine? Like,
yeah,
this is the sort of shit that she does. It's amazing.
So somebody says that it's like ceramic, it can take enormous heat, but mostly likely brittle as hell.
Do you have a hammer?
Crank this down here. Can I? Okay. We got a lag here, so you gotta tell me.
I mean, we see your keyboard.
You see what I'm doing?
We can see your keyboard.
You see what I'm doing?
We can see just your keyboard. We just see your keyboard. Oh god. Oh god.
How about that? How about that?
All I see is shaky. Okay, yes. Now we can see that. Oh god. Now we see the bottom of your laptop. Okay. I mean, we can kind of see that. It is not brittle at all. This stuff is really tough. Like really tough. Especially when it's that thick.
But most of the things alive on the planet that are not plants are made out of this.
I think it's pretty safe to say you could hit that with a hammer pretty hard and it wouldn't break. It might chip.
Actually, I just don't want to go get a hammer.
Right. I mean, this is the sort of thing. Like it's ridiculously tough material.
Somebody asked how easy is it to make at home?
Very.
Am I centered again?
Again, you're centered. You're good. You're centered.
Okay. Yeah, how easy is this to make at home? The first time we started doing chitosan research, Justin and I and Jordan were in Chile, and we didn't have access to a proper lab. And
fucking understatement of the year. Did not have access to a proper lab. No shit. We were up in the Chilean mountains in a random house.
Yeah, cooking chitosan in an old school wok on a gas stove in Chile
God, that was awful.
to make some of our initial samples. And Jordan managed to make a pair of flip-flops. And then she walked 2 kilometers in them.
Yeah.
So
that was
so
pretty
how
dope.
easy is it to do at home? Easy as fuck.
Also,
How
you can
easy
buy
is it to
chitosan
do?
on Amazon. You can buy it on eBay. You can buy it in most health food stores, actually.
Yeah, you can also go to Alibaba and they'll be like, "Hey,
how many metric
we'll
tons
send
would you like?
2 kilos as a sample, but would you like a 50-gallon drum
Yeah.
for like $75?"
Yeah, stuff is
Because it's a
really
waste
fantastic.
product. That's the best part. It's garbage. People eat shrimp, they throw it away. Somebody collects the shrimp shells, they turn it into chitosan.
Yeah, I mean, so my plan
It's
with the spider silk, for example, does include at some point growing a bunch of spider silk protein, mixing it with chitosan, making it in plates, and then shooting it and seeing what happens. Which I assume the bullets are going to get about halfway there, go fuck this, and leave. Like.
And yes, by the way, yes, I do have time to blowtorch because my blowtorch is here for sterilization techniques. I'm in the lab. I don't have a hammer in the lab. Sorry.
But yeah, so if you haven't seen, Neri Oxman has a fucking phenomenal TED Talk. Like, most TED Talks are wank. Let's just be really clear about that. But her TED Talk is frickin' amazing because there's not a single thing she talks about that I'm like, that's the coolest thing I've ever seen in my life. Like,
So
consistently.
cool.
She's so, God, I want to meet
So
her so
cool.
bad. Like, there aren't many people that I like make loud fangirl noises about,
This is my
but like,
science. This is what I'm going to science fangirl over.
oh, 100%.
I'm going to science
like,
fangirl over Neri Oxman. Elon Musk can suck 15 fucking dicks.
yes,
But
seriously.
Neri Oxman is cool.
Right. Like, this is the thing.
She is
Everything
the
Neri
real
Oxman
deal.
does is dope as hell. Everything Elon Musk does is mostly shite.
Yeah.
This
So,
is just
you know,
put
Neri
that
Oxman
out there.
trade people.
Yeah, so Neri Oxman, fantastic. Highly recommend checking her stuff out. In fact, I'm going to just look this up. Neri Oxman TED.
Someone asked for the insulation properties.
Yeah.
Chitosan is used as an insulator.
Okay, yeah, so the TED Talk is called Design at the Intersection of Technology and Biology. Watch it. It's 17 and a half minutes long. Like, make yourself a cup of tea, sit down, watch it through, because it is just fucking
Worth it.
phenomenal. It is absolutely worth it. It will, like, I'm not going to say it's going to change your life, because I'm not a huge wanker, but
Shut up, it changed your life.
but it did change my life. So,
Yeah.
like, legitimately, the
Shut up, it changed your
things...
life.
The
So I
things
sat you down and I was like, you need to watch this video.
It did, and this was like 5 years ago, and legitimately most of the research that I now do comes from inspiration that I got from watching this video. So, like, fucking go watch it. Like, I cannot recommend it enough. It's so good. Okay, let's keep talking about chitosan. So we talked a little bit about how it could be used for for transfecting cells, because, like we said, chitosan can be used for fucking everything. So
And we
basically,
are working on the next generation of the
lactase
lactose
thing. Yeah.
thing. Yeah.
So for those wondering, the lactase thing is still happening. Turns out,
shit's getting good right now.
I know. How have you gotten any updates on that? Has it been finished?
No, they're sequencing.
Okay. But I mean, that means they're mostly done. Like, if they're at sequencing.
Half done.
Half done. Okay.
Usually they sequence and then they gotta go back. But anyway, we're
Okay,
there
anyway.
about half.
Point is, the next version of the lactase thing is coming along. So one of the ways that we're changing how we're doing things is we're using chitosan to deliver the DNA, because then we're not using a virus. We're using DNA, which is easy to grow and cheap. And so basically we're taking chitosan, which costs pennies, and DNA, which costs pennies, and putting them together into a thing that should solve a problem that 60% of the human population deals with.
Hang on.
And we're making it
I'm
open
sorry,
source.
This is a really weird question, but somebody asked, does it absorb energy? The chitosan is still very warm from blowtorching like 30 minutes ago. It doesn't burn. It just soaked it all up.
Yeah.
It's toasty.
Yeah.
Not burning.
So for people asking how you donate, there are links in the description, or you can use Super Chats, but I would highly suggest using the link in the description, because if you use a Super Chat, YouTube wants their pound of flesh, because they be YouTube, and so that's how they do, and they take 30%. Because for reasons that I don't understand. But yeah, so use the link in the description, and you can pay through PayPal. Anyway,
why would we charge $3,000 for a lactase pill?
We're gonna charge about $4.
A nickel?
A nickel? Yeah. What do you want? Like one shiny nickel.
I need a nickel, but it has to be minted before 1980. That's my that's my right there. Okay.
So we've had a couple of donations. Nick Todd, thank you very much. You just donated. Vithar Gabriel Vithar. I don't know. It says, this is much, but thanks for the awesome work and the awesome videos. And a question: how Cytosine can be used for environmental remediation? We're getting there. We're getting there.
We're getting there. Don't worry, buddy.
Don't worry. It's on the list, because of course it's on the list. It's Cytosine. Also, No Name just donated $5. Thank you very much. Greatly appreciated. Okay, so I mean, let's just finish up the transfection thing. So here is a comparison between using Cytosine and using lipofectamine to get DNA into some mammalian cells. Now, lipofectamine is the go-to compound when it comes.
Standard.
It is the standard. We've used it a bazillion times. I even used it in the original lactase thing when we were first getting the DNA into the cells that we grew the virus in.
I'm about to use some lipofectamine after this call.
Right. So lipofectamine is super. It's super common, but it's also quite expensive, and it also is fairly cytotoxic, which means it also kills a lot of the cells. Whereas I'm gonna make this a little bigger so you can see it. Here's a comparison between using lipofectamine versus Cytosine to put some green fluorescent protein into mammalian cells. You'll see that the lipofectamine ends with more fluorescence in individual cells, but on the whole, more cells took in the DNA when using the Cytosine method. So this is actually really helpful, because having more cells produce the DNA is better than having a few cells produce the DNA really well. And so if I scroll up, you can see here's some different comparisons. So this is the cell viability. You can see that the cell viability when using the Cytosine is almost 100%, like almost none of the cells die. Whereas if you use the lipofectamine, almost 50% of the cells die. So this is really, really cool. In a paper that I don't have pulled up, but I've shown in the lactase update video, there's a paper where they did this specifically with intestinal cells in a living rat. So they made Cytosine nanoparticles, and then they mixed those nanoparticles with the DNA, and then they just fed it to some rats. And the entire rat's digestive system started producing lactase. Like, they stained it with a dye that interacts with lactase, and the whole thing turned blue. Compared to the control rat, it stayed perfectly yellow. So it's really, really fucking wild, and it's really cool. And you can see that when you look at the amount of fluorescence that's generated, it's almost on par with the lipofectamine. So it works just as well as the standard, it's cheaper, and it works better, like on average. So, and it also can survive a trip through the stomach. It can transfect living tissues outside of a flask. Like, it's a fantastic compound, and it's super useful.
Yeah, and it's also biocompatible. So, like, you can totally just... Yeah,
it's also biocompatible. That's really the cool thing.
They use it for medical devices. They use it for implants. They use it
for
all sorts of stuff.
Like as coatings, because there's some papers that use it to make coatings onto things, because then your tissues will actually stick to it better and makes the implants hold in place better. Like it. When we're saying that there's very few things that Cytosine can't do, we're serious.
We're really serious about
I think the
this.
only thing I can't...
Like, if you're not in love with Cytosine, you're in love with the wrong biomaterial.
If you got a problem with Canada Gooses, you got a problem with me, and I suggest you let that one marinate.
Yep. Acetic acid 3%, because that's how it dissolves.
Yeah. Anyway, so that's transfection. So it's already useful in the lab. Let's talk about bioremediation, because I mean we had a question about it, and I think it's about time that we do that thing. I'm just trying to see if I can find it. Was this one? Okay, good. So Cytosine also attracts ions and oil and all kinds of other things, and you can mix it with other.
Tats.
Sorry, I know. but it's particularly good at collecting heavy metals. So it's being used to purify wastewater. So, for example, we while we were in Chile, one of the things that got worked
The
on.
technical term is flocculant.
So flocculant just makes particles stick together. It's actually an ion
But
absorbent.
it also
does.
to heavy
Oh,
metals.
also, while we're talking about flocculants, it can be used to clarify wine. And
Yeah.
it's like one of the things it's used for is you mix it with wine that's cloudy, and then you get perfectly clear wine afterwards, or beer. Like, it's so cool. Sorry. But so it also is particularly good at absorbing heavy metals. So people have been making it into like little beads, basically. And then you can mix these beads in with wastewater that you're treating, and it'll absorb all of the toxic heavy metals, and the water that you get out is cleaner.
We super fucked up, dude.
What?
When we filmed that video where you did the sonication,
Oh, we should have chitosaned it.
he didn't put chitosan in it.
That's funny. Yeah, we should have done that. It would have been good. Whatever follow-up video.
All right, follow-up video. We're gonna do the same thing, but with chitosan, because chitosan
basically
makes everything better.
Right,
Dude,
so like you can get the flavor
okay,
in.
hang on, I gotta Google this. Chitosan milk. Have you Googled this?
No. Is this the thing?
Hey, your deer milk is coming in the mail. Okay,
I'm so excited. Oh yeah. Also, since we're doing, since you oh Jesus. Since you mentioned it, the because people have been asking, the deer milk has officially been synthesized. The egg plasmid is almost done. So soon we'll be getting those into some yeast, and then we're gonna have deer milk. Who's excited? This guy, and then I'm gonna make deer cheese.
And evidently, one of the best ways to make a good cheese is to add chitosan.
Oh my God! Seriously?
Yeah, I just found the paper.
Fuck's sake. Chitosan.
Used to chitosan in dairy products production.
Cheese. I'm just writing chitosan cheese.
Significantly reduces energy costs in the processing of milk proteins and carbohydrate raw materials. Boosh.
What in the actual fuck?
Put the deer milk with the chitosan. You put the chitosan in the coconut, and you shake it all up.
And it probably makes it better.
It's basically a genetically engineered deer.
Oh my God. Yeah. Holy shit. This is chitosan makes better cheese. Because of course it does. It'll also probably cause way more reactions because chitosan is immunogenic and people can be allergic to it. But
true. But that's only if you don't have the purified ones. Like really, people are allergic to the proteins in the shrimp shells, not the actual chitosan.
Oh my God.
So
effects of chitosan coating containing lysozyme on cheese production.
Yep.
Of course. Okay. Optimizing.
Yes.
It's
chitosan all the time, baby.
Fuck. They're using it as a coating for cheese, instead of wax because apparently it works better. And also we haven't mentioned it's antimicrobial. Oh
yeah, it's also antimicrobial. So
so you can use it as like
food, and food is better. Like
I'm telling you, just like we need to just coat all surfaces in chitosan, and it'll just be better. Like, so we just had a couple of questions, and we had some more donations. So I just want to address these really quickly. Somebody asked how much heat can chitosan handle. So Gabe just took a blowtorch to it, so a fair bit.
But then somebody also said, so they're looking at melting point of chitin, and they're also looking at melting point of chitosan. So that's like 290 to 300 degrees.
Yeah,
centigrade.
But it doesn't really melt. It burns before it melts.
Yeah, and then on top of that, this has been processed. It has already been like, I'm going to say mechanically cross-linked via baking.
Yeah. Also, that's the other thing. Like the properties, you can't use the base properties as a good reference because there's so many ways you can modify it, and also the things you mix into it radically change its properties. So if you were going to make an ablative material for reentry, you're going to be mixing it with probably some like aerogel powder. Like if you took chitosan and mixed it with aerogel powder, like that shit would probably survive reentry just fine. Like
Just to clarify, though, this is not a blend. This is pure chitosan.
Right, and so that's what it's
There is
like
no other
before you mess with
secondary
it.
materials in this thing. It is just a brick of chitosan.
Band gap.
Yeah.
I'm just seeing if it's also a semiconductor, just because fucking why not?
Sure. Oh, okay. Oh, okay. Quick. Who gets the chicken dinner? Winner, winner. Chitosan.
What? There's the tuning the. Oh my god.
Chitosan for sensors and electrochemical applications.
Yeah, we've got. Oh, here we go. Here's all the buzzwords. We got chitosan and graphene. So if you mix graphene and
nanocomposite.
There you go.
Photocatalytic.
There we go.
Sensor.
Also, like, you can mix it with like copper nanoparticles, and then it can be used for like some really interesting catalysis. Like there really is almost nothing you can't do with this. I'm already seeing in the comments somebody being like, "I bought an ounce." Good. Everybody should. I don't know if you can make a diode. I think you've got to mix other stuff into it, but you could probably make a diode. Like, I need to see somebody. Oh, here we go. Somebody's using. Yeah, here we go. God, I'm just click on this because I want to see what it is. Crystallinity and lowering band gap induced visible light photocatalytic activity of titanium dioxide chitosan nanocomposites.
There you go.
There we go. We're using chitosan and frickin' titanium dioxide to catalyze stuff. Okay. Like, this is like it's a carrier. It can be used for like so many different things. If you're making like adhesives, you can mix a little bit of chitosan into it and it becomes a better adhesive that's stronger. Like, it's just so cool. Like, you can cross-link it to stuff. You can cross-link it with other stuff. You can mix it with other biopolymers, and that gives you radically different properties. So, like, mixing it with casein, you get, like, a really cool rubbery material, which is what we showed before. So, like, once I've got my deer milk, I'm going to grow a bunch of deer milk, and then I'm going to mix a bunch of chitosan into it, and make some shoes. Or something, I don't know.
Definitely chitosan deer milk boots. That is the boat.
Right?
Right now.
I hear people want more merch. Chitosan deer milk boots?
Chitosan deer milk boots. Sure,
Okay.
why not? Okay,
Why not?
So what else do we have in the tabs for
Chit-
shit that chitosan can do?
Oh, I've been seeing a million comments for chitosan aerogel. So yes, you can make it into aerogel. And then yes, you can carbonize it and make it into super lightweight frickin' foam. But here we go. Here's some chitosan aerogel. Happy birthday. Chitosan aerogel. Totally works. You can also carbonize it after that and make super lightweight materials. Like,
See, I made that. I showed the picture of this thing.
Right.
I had it.
Yeah, but I mean, you didn't have an aerogel. Yours wasn't super critically dried. It was freeze dried.
Yes, that's true.
It's a slight difference. You get a lower density on the other thing.
It's very beefy though.
Yeah, I mean, so here we go. Here's some chitosan aerogels. Here's a piece of chitosan aerogel on a single blade of grass that is not deflecting it at all. Like, it's chitosan, man. Chitosan can be used for everything. Can it be injected, molded? No. That's the one thing that it has issues with, because you can't melt it. So you've got to, but that's only talking about pure normal chitosan. There are ways to modify it to make it melt. So,
also, if you look in the library, in the chitosan folder, there is a paper about making chitosan injection moldable.
because of course. So yes.
Because of course.
Yes, it is possible, but it does take a little bit more effort than just like booping some chitosan goo into mold. So it says, can it be melted in a vacuum? Probably. It's still probably,
I mean,
but the problem is it's a sugar though. So like even in a vacuum, it contains oxygen in large quantities of it, so it'll still burn.
Yeah.
So it's
right.
hard. It's hard to get to melt. You have to actually modify it to get it to
Cool
melt.
things that chitosan can do.
Yeah.
What other tabs do we have open?
Something about cardboard. your weird stock image that you made me open?
Oh, right. Okay. So, um, yeah, right. So this is a type of thing called structural engineering, which is like a very, very like niche form of uh, chemistry, actually. I'm going to pull up my notes here on this. So this is like a very, very niche form of chemistry in as much as that, okay, so technically, in the same way that when people talk about nanotechnology, they're really just talking about chemistry. Like you're not going to have little robots unless you're just having atoms doing things. And then that's just chemistry. So on the other oddly opposite end of this, and so this is one of the reasons that like, and so I'm going to try to tie this together with the Cytosine thing. One of the things that I'm really excited about is this concept of modifying the surface, like the macro structure of a thing, to do something without actually having to do the chemistry, because I'm lazy. But also, evidently, these people figured it out too. So have you guys ever gotten this fancy packing paper before? This is like people's response to bubble wrap. And so this is just a piece of paper. But then they gave it this scalloped cut. And the scalloped cut, cardboard packing paper. Yeah, you're still going to get the same thing. You're just not going to get that beautiful image that I gave you. So yeah, that's all garbage. Nope, you ruined it.
I'm just trying to get a better image.
So by actually having a change in the surface of a structure, you can get a different type of material property. And so doing chemistry and even biology is not always about fucking around with chemicals, but it's sometimes about fucking around with shapes, which can be weird for people to like get into their head sometimes. And so like you saw some of the CHITOSAN that I had, and a lot of that just has to do with changing the shape of how the CHITOSAN is sitting. Because it'll just dry into a flat sheet and look like a pane of glass, brown pane of glass, but a pane of glass. But you can also foam it. You can freeze dry it, so you can vacuum it to make bonus foam. You can bake it. And so this stuff is awesome because this is just a piece of paper. But when you change the surface of the paper...
here it is. Yeah, there we go. That's a better image.
You can actually change the material properties, and so it'll hold a shape or it'll become poofy, even though it's not like necessarily poofy. It's just poofy. Do the one with the cat. Why are we not looking at the one with the cat? Yeah, but that. And so this is one of the, like when I was working in the chemical engineering lab at UW, I had a piece of this tacked over my cubicle because that's what you do, right? You hang things in your cubicle, and I hang packing paper, evidently. And it was to remind me that the solutions aren't always about changing the chemicals in a thing, but sometimes it's just about changing the shape. And so if you're dealing with chemical engineering, sometimes they'll talk about brushes. So if anybody here has a background in chemistry, you know about polymer brushes, which is basically you have a polymerized surface with molecules coming up from the top. Now, of course, you can't see that, but you know it's there because you know chemistry, and fingers crossed because that's how you have to do it. And also, thank God for scanning electron microscopes. But then you can also alter the heights of the different parts of brushes. And so one of the things that we've been trying to do with CHITOSAN is not just change the mixtures, but also change just how it's structured. And so we've been doing poofy stuff. And so surface engineering is like one of my favorite things.
It is. Also, just quickly, we had a question about, can it be colors other than brown? Yes. You can totally dye it.
Yes.
Here are some pictures of chitosan being colors other than brown.
Yeah, and so I was kind of like vibing out, talking about this type of stuff. But so somebody somebody was so it looks like Scrap AI jumped on it, talking about like in bio, the lotus leaf is the quintessential example of structural modification versus chemical modification. And so completely hydrophobic, fantastically hydrophobic, and it does it because of the shape, not because of the chemicals, not because of the material on the surface, but because of the shape of the material. And
yeah, well,
so
I mean, it's lots of waxy hairs. It's like...
Well, no, you got to get down to the nano. But I mean, yes, that's beautiful, but you got to get down to the nano. Because when you get down to the nano, it actually, like, I worked with some people that were trying to mimic this, and you have to go in and you have to try to build chemical structures that are mimicking this structure, but you're still at that level.
I stand by tiny waxy hairs.
I mean, okay, nano waxy hairs.
Yes.
And it's not waxy. It's not the waxy. Actually, it has to do with the gap in between the hairs. So it is a physical thing. It's not about the waxiness. It's actually about the gappiness in between. It's the physical structure that does the thing. Yeah,
but no, like all super hydrophobic materials have to be at least a little hydrophobic. If they're not, this structure would be extremely hydrophilic. Like water would stick to this extremely well if they weren't at least coated in wax.
There's definitely other things going on, but also we tested this in a lab.
Yeah, but you have to have some amount of hydrophobic coating or it won't work.
No, they found that the gap, the small micro gaps, the nano gaps between the structures actually are more efficient than the waxy coating.
Right, but you can't have...
Because they can do it with a non-waxy surface. We made this with glass. Yeah.
That doesn't sound right.
I know. That's why it's so cool.
All right. But anyway, so yeah, chitosan's dope.
Exactly. The gap is smaller than the adherence spore system.
Yeah. Okay.
Anywho, so chitosan.
Yeah. So I've exhausted my list of tabs. Were there any other?
And also have some stuff to do.
I do. I mean, I think we might just call it early today. So let's take a few minutes to get a bunch of. Let's take a couple of minutes to do some questions, and then let's wrap it up, because I do actually have to go early today.
Okay, there is actually one question that I saw from Lamageddon that I saved in a notepad so that I could remember. Do you keep a list of chitosan applications, including the different bioplastics, somewhere? No, because it's ever. But
I was going to say that.
But I can make this list. For you, Lamageddon, I will make this list. And we will throw it in the library. I'll have Ainsley take care of it.
I'm like 90% sure that my asshole neighbor is smoking a cigarette right now, and now my entire apartment smells like that. It's really fucking gross. Sorry. I know. This has nothing to do with anything. Yeah. I noticed it, and it's really bothering me. Anyway, all right, so let's talk about questions.
Can you combine it with kombucha leather?
Yes.
Back to Nakara.
I mean, we've tried coating kombucha leather with chitosan, and yes, it totally works. It makes it great.
Yeah. Also, the Nakara King also needs a sheet of cellulose material sandwiched in between the silk and the chitosan, right? Am I forgetting this? That's correct? I'm pretty sure.
There's no cellulose.
There's a cellulose there.
There's no cellulose in the nacre. It's just chitosan.
Is there not?
Nope, it's just chitosan.
Okay. No, but it's not just chitosan. It's chitosan silk.
Well, it's chitosan silk and calcium carbonate, but there's no cellulose.
Okay, there's no cellulose in that one. Okay, so in another paper, somebody else is making chitosan cellulose layers, and so this is a whole nother thing. Just keep digging into those papers, guys.
Yeah, the thing is, like, you can literally spend a lifetime reading all of the papers about chitosan. like multiple lifetimes probably. Like I feel like a solid like 5% of Sci-Hub is just about chitosan. Like,
I mean, yeah.
Okay, what other questions do you got? Otherwise, we're gonna wrap it up.
Okay, there's a question. If chitosan is so powerful, why does nature use chitin instead? That's because we're dorks. We're turnips.
Yeah, we're bad at chemistry.
Chitin is dope, and animals use proteins to cross-link it, and they also bind it with calcium carbonate.
Also, they synthesize it
Evolution is
directly
cool.
as chitin. We can't.
Yeah, and they just kind of leak it out of their flesh.
Yeah,
Whereas
in whatever shape they want.
Yeah, whereas we are crappy little turnips that need to turn it into a powder and then functionalize it and then dork around with it. This is all reverse engineering.
Yeah.
Nature uses chitin because chitin is better, but we don't know how to chitin.
Yeah.
Chitosan is our baby step. It's
Basically.
our we're radishes step.
Essentially. Okay, what else we got? Solar panel applications. I don't know, maybe.
Sure.
Shrug. I don't know.
Yeah.
Look it up. See if it's a thing.
I'm gonna look up chitosan solar panels.
Yeah. All right. What else we got? Yeast that might make chitosan.
Yes, it's a solar panel.
Of course it is. There are some papers on using yeast to make chitosan, but chitosan is so readily available that there's no point. Like, it's easier to just go fucking make yourself a nice shrimp dinner. Save the shells. Because, I mean, like, there's 3 uses for shrimp shells. Fertilizer, making chitosan, and really dope stock.
Yeah. Shrimp stock.
Shrimp stock is great. Like, it's also, like, if you ever make lobster, which, I mean, I realize that's sort of a rarity. I mean, depending on where you live, like, it's an expensive ingredient. But if you ever make lobster, don't throw out the shells. The shells are where all the flavor is. You roast them, and then you make them into stock, and they get real good.
Yeah.
There is chitosan thread is a thing. Chitosan fibers, it's a thing. Like,
yeah, didn't you make some chitosan fibers when you were in Florida?
I tried to,
Yeah.
but we didn't have a concentrated enough chitosan. But here's some beautiful chitosan fibers. Like, yeah, you make chitosan fibers. Chitosan fibers, no big deal. Here's some more chitosan fibers. You get chitosan fibers, and you get chitosan fibers. Yeah, you can make clothing out of this stuff, no problem.
Those are pretty.
What about in food? What about in
these.
food production? We already talked about food production. It's being used to make better cheese. It's used as a flocculant in beer and wine production. It's used as a fiber supplement.
It's used as a coating to protect vegetables.
It's used as a coating to protect medicine. So, like, one of the coatings you'll find on pills is chitosan.
All right.
Yeah. What else we got? Metal organic framework and chitosan. I don't have any links to that, but you're free to Google it. Like, it's a thing.
Sure, we're just gonna. This is what we're gonna do for the last 20 minutes.
Basically.
We're just gonna.
Can you make
chitosan metal complex?
Wait, can you make a kitchen knife? There's that one YouTube channel that just makes knives out of weird shit. I had put money on him making one out of chitosan already. Like, it's probably like if you sent me that brick of chitosan stuff, I could probably sharpen it into a knife. Yeah.
I will sharpen the chitosan.
Can you make spaceships out of chitosan? Well, it can already be used as an ablative, probably be used as an ablative material for re-entry. So yeah, chitosan spaceships. Do you think there might be other exotic sugar polymers with properties that are as or more astonishing? There are a lot of really great polysaccharides that do all kinds of interesting things. Trehalose is a really cool one. Cellulose is a really great one. Then you get into like all the really weird ones. Like, I mean, conodritin, I believe, is also a polysaccharide. I want to say. Conodrite.
Yeah. So the way that I look at it is, it's the second most bioavailable material on the planet. So there are probably other niche, interesting polysaccharides.
Yeah, conodritin.
But like, Oh, there you go.
Chondrodritin, which
Yeah.
for those who aren't aware of what chondrodritin is, chondrodritin is cartilage. So,
Yeah.
um,
Oh, yeah. Ooh.
yeah,
Wait. What is this? Hang on. Yeah, but like, there's a whole bunch of stuff. I mean, that's why we use cartilage for fishing hooks and all
sugars be
sorts
dope
of.
is I think the
Um,
thing. I know how much you hate
yeah.
sugar, but
No,
polysaccharides
but I
are pretty
love.
great.
I don't. I hate sugars. I like carbohydrates.
Okay. Yeah, everything is freaking. If it's organic, like if it's alive, it has some interesting polycarbonates in it somewhere. It's just how it goes. Could you add it to concrete? I would bet my bottom dollar that you can add chitosan to concrete.
This is just my new game. You guys are gonna tell me. You're gonna come up with weird stuff. Yes. Boom. Paper.
Chitosan
Many papers. Many papers on this. People love chitosan concrete.
Chitosan concrete is great. There we go.
Yeah. Yep.
There we go. Yep.
There we
Chitosan
go.
concrete makes your concrete better. Fibers for optics, probably not. Its optical properties are fine, but I wouldn't like. Glass is better, like, because you can like it might work, but I don't see that being a great choice. Like, yes, it can work for all kinds of things, but like there are still better choices for certain things.
There are a lot of papers about optics and chitosan now.
Oh my god.
Yeah, see, I'm sorry. Like, I have not put enough papers in the library, evidently.
Yep.
Um,
What the fuck? This is a non-linear optic. Are you kidding me? They're making frickin'... they're making quantum entangled particles using chitosan. What the fuck? Like...
yeah, see?
Oh my
chitosan,
god.
Good for everything.
optical
You're
activity.
gonna have to do a
Oh
video.
my dude,
You're
look.
gonna have to do a video on this.
Optical activity and isotropity of chitosan-based biofilms, so you can use it as like polarizers and stuff. That's just wild.
Yeah.
Okay, well, I give up. It's chitosan is amazing. I just, does anything eat it? I mean, lots of things eat it. Chitosan is very readily biodegradable. Yeah, like one of the reasons we're using this is because if you put it in the ground, it becomes ground. Like it gets broken down very easily.
Yeah.
So yeah, this is chitosan is wonderful. But I think we should probably wrap it up.
Yeah. Okay. Wait. No. Somebody said transistor, and that sounds like.
Well, I mean, somebody already
That's
asked, that was what they were asking when they asked about the band gap earlier.
Yeah, there it is. Protonic electronic hybrid oxide transistor gated by chitosan.
Oh my fuck.
Yeah.
Chitosan
sexy.
transistor, because of course it fucking is.
Yep. Yeah.
Of course there fucking is. Oh my god. Yeah, no, here we go. That is a chitosan transistor. I give up. I'm done.
Yep.
I give up. We can
Yep.
make chitosan computers.
Time to pack it up. Time to pack it up.
Oh, here we go. Here's all your buzzwords. Here's a chitosan graphene oxide transistor. Yeah, there's your gate. There's your drain. There's your sink. Yeah, that's a transistor. That is a proper transistor made out of fucking chitosan. Okay then. Okay, I give up. I'm done. I'm done. I'm fucking done. I'm just fucking done. I'm just done. there's chitosan.
Okay.
I think on that note, we're gonna have to wrap this up because otherwise my brain is just gonna liquefy and fall out my ears.
Yeah.
Okay, well, so this has been a lot of fun. Thanks everybody for hanging out. We'll be back with another stream next week. I might do a Who's Gene on Tuesday. We'll see. I am working diligently on the new video. The new video that I'm working on is 40 minutes long. It is the longest video I have ever made by a fair margin. It is requiring more animation and more graphics than any other video I have ever made. And I have been filming it since fucking January. So it is a massive, massive video. It is taking me an enormous amount of time, so I might just not do a stream early next week because I want to just sit and edit and animate and do more stuff. So, be excited for that. Couple other little announcements. If you haven't, it's not the Silk video. It's about the pandemic and how testing works. But it's going to be a really great video. I've spent an enormous amount of time and effort on it. I'm collaborating with people literally all over the world to make this happen. I've spent an enormous amount of money on it. So much so I try not to think about it. But it'll be a really great.
What else are you gonna do with it?
Right, exactly. Can't take it with you. But I think it's gonna be a really great video. But I might not do streams so that I can focus on doing that, because I just want to get it done. I've been working on it since January, and I want it out of my brain. And I think you guys would enjoy it, so I want to get it out as soon as I can. So that might be that. If you haven't already, there are some new videos on my second channel, The Taste Emporium. I would highly recommend checking those out. I am starting to work on a new video for that channel, but that's going to come after 2 videos on this channel. So I'm doing the video about the pandemic, then I'm doing a video about some hologram stuff, and then I'm doing a video on the food channel again. So be sure to subscribe to that. It'll be fantastic. Thank you, everybody who has donated. It is super, super duper appreciated. There'll be more updates and stuff coming. If you're a patron or member, be sure to join the Discord. If you're not a patron or member, you can join the Sci-House Discord, because that's open to the public. Links are in the description. With that, I think I'm gonna wrap it up. Thanks everybody for hanging out. Gabe, thanks as always. It's been a lot of fun.
Yep.
And I will see you guys next time. Bye bye.
Ciao.